Alright, so in this video, which is the second subtopic of the partial fractions topic, we're going to look at how to split fractions containing irreducible quadratic factor in the denominator into partial fractions. So, by an irreducible quadratic factor, what we mean is a quadratic factor, so that is something to the second degree with a x squared term, which cannot be factorized. And so the way to check this, let's say we have x squared minus 2x plus 3. Well, the way to double check that it definitely can't be factorized is using b squared minus 4ac. So you should know this from a while back, that this is ax squared minus, plus bx plus c. So here b is equal to, a is equal to 1, b is equal to negative 2, c is equal to 3. And now you can use b squared minus 4ac, and if this is less than 0, then this cannot be factorized. So in this case, this is 4 minus 12, which is equal to negative 8, and negative 8 is less than 0. So x squared minus 2x plus 3 cannot be factorized, at least with what you know so far. Also with one of the last topics, you will realize that this can indeed be factorized. So that's how we check that it's not factorizable. And so the method now is a bit different. So we're going to go into an example so you can see the equivalence. So 3x squared minus 2x minus 5 divided by x plus 2, and I'll just reuse the same one because we've already shown it's not factorizable, plus 3. And its equivalence, so the step where you have to turn it into an equivalent fraction. First of all, numerator degree 2, denominator degree 3, so that's fine. And so this is equivalent to a over x plus 2 plus bx plus c, I made the fraction bar way too big, bx plus c over x squared minus 2x plus 3. So basically, if there's a quadratic factor, it's going to go under some unknown times x plus a different unknown. Alright? So remember that the letters don't matter. Often they don't in maths if it's letters, unless it's like a constant. But if it's just an unknown, you can technically use what letter you want. We use A, B, and C for consistency. So how do we solve this? Well, we'll go for all the steps, turning it into one fraction. This is equal to a x squared minus 2x plus 3 plus bx plus c in brackets times x plus 2. Then we divide that by x plus 2, x squared minus 2x plus 3. And now we can cancel the denominators. This denominator cancel this. And so we get that 3x squared minus 2x minus 5 is equal to a x squared minus 2x plus 3 plus bx plus c x plus 2. So this might seem a bit overwhelming, but let's first of all see what simple thing we can do. Well, we can pretty easily solve for a, right? If we set x equal to negative 2, this whole thing disappears. So this side becomes 3 times negative 2 squared, which is 3 times 4, which is 12, minus 2 times minus 2, which is minus 4, so plus 4, so 12 plus 4, 16, minus 5, 11. So 11 is equal to, so a is coefficient of a is minus 2 squared, which is 4, plus 4, 8, 11. So 11 is equal to 11a, which is quite simply a equals to 1. And now this is a different step. This is where it changes. And what happens is that we need to equate the terms. And what that means is that we're going to make, basically we're going to expand the brackets, right? So 3x squared minus 2x minus 5 is equal to, so a is just 1, so x squared minus 2x plus 3, plus, now expanding the brackets, bx squared plus 2bx plus cx plus 2c, okay? And of course, the x squared terms have to be the same on both sides, and so do the constant, so does the x terms, because if x changes, it needs to change in the same way on both sides because they're both equal. So it's not like you can say, oh well, maybe 2x minus 2x plus c x is equivalent to 1x squared. No, it cannot be equivalent. The power is very important, and so what you can do is what we call equating the terms. So we need to have the same coefficient for x squared on both sides. So this is just 1 here. So 3, which is a coefficient on this side, must be equal to 1, which is a coefficient here, plus b, because b is the other coefficient. And so this means that b is equal to 2. And now we can similarly do so for the constant, which says that 2c plus 3 must be equal to -5 for it to be equal on both sides. So 2c plus 3 is equal to -5, which means that 2c is equal to -8, which means that c is equal to -4. And so now, believe it or not, we have a, b, and c, and all we need to do is just plug it back into the original fraction. So, let's see, so a is here, so 1 over x plus 2, then b is 2, so plus 2x, c is -4 minus 4, divided by x squared minus 2x plus 3 is equivalent to our original fraction. So we split it into partial fractions, and it can't be split any smaller because this is an irreducible quadratic factor. So let's see if I can maybe get another example of this. Right, so let's say, the problem with partial fractions is it's a bit harder to make up questions on the spot because they risk having very nasty fractions in some places. So let's see, we'll do 5x plus 3 divided by x minus 3, x squared minus x plus 3. So press pause and have a go and see how you get on. Alright, so assume you've tried. Step 1, if there's a suspect irreducible quadratic factors, to make sure it is indeed irreducible. So here b squared is just 1, minus 4ac is minus 12, which is equal to -11, which is lower than 0, and so this is irreducible. So, okay, now we know what equivalence we're going to look for. This is equal to a over x minus 3 plus bx plus c over x squared minus x plus 3. And so we can now start solving this. I'm not going to do the whole fraction thing. You should know by now that this means 5x plus 3 is equal to a x squared minus x plus 3 plus bx plus c times x minus 3. If you don't understand how we got from here to here, from this equivalence to this equivalence, then you can go through all the steps of putting it under one fraction and cancelling the denominator, but I don't think that's necessary by now. Now we can solve for a by plugging in x is equal to 3. So if x is equal to 3, and this side is equal to 18, and that's equal to 3 squared is 9, minus 3 is 6, plus 3 is 9 is equal to 9a, which means that a is equal to 2. Now we can plug this back into here and expand the brackets. So 5x plus 3 is equal to, so if a is 2, then all this becomes 2x squared minus 2x plus 6. Then this is plus bx squared minus 3bx plus cx minus 3c. And now we can compare coefficients. And interestingly, there's no x squared coefficient here, which means that 2x squared, which is here, plus bx squared must be equal to 0. Which means that b must be equal to -2, of course, so this is opposite of this and it removes it, so b is equal to -2. Alright, now we need to solve for c, and to do this we're going to compare the constant term, so 3 must be equal to 6 minus 3c, which means that minus 3 must be equal to minus 3c, which means that c is equal to 1. And plugging all this data back into the original expression, we get, so this is equal to, where's a, 2 over x minus 3 plus, so b is here, minus 2x, so because we did negative here, this one's actually going to be -1 divided by x squared minus x plus 3. So well done. You now can solve for two types of partial fractions, which will help you. There's nearly always a partial fractions question in exam, although interestingly it's never on its own. It's always within the integration topic, which is what we're doing after partial fractions, because you need partial fractions to do one part of integrals. See you in the next video.